Hello everyone, we will start our course now. And today's topic is about EIPs and ERCs. And it's me again. I delivered the Solidity basic course in last week, and I'm a blockchain developer, a tech writer, content creator, and a core dev at IS3 and Crossfire. And I deliver some Solidity course and a tutorial, and I'm a contributor of OpenBuild. And about today, I will explain the EIPs and the ERCs about their process, their types, and maybe their definitions and their differences. And I will also coding practice about the ERC20 and the ERC712 and other ERCs. And now, so you may heard of the EIP, maybe EIP20 and the ERC20. If you are not familiar with their items, I will explain them. What the EIP is. EIP is the Ethereum Improvement Proposal, and it's a process that allows members of Ethereum community, including developers, researchers, and users, to propose improvements or changes to the Ethereum protocol. And the EIPs are formal proposals that describe the rationale behind the proposed change and the technical specifications and the potential impact of this change on the Ethereum ecosystem. And most of the EIP topics are about the change to the Ethereum virtual machine, also the EVM and the Ethereum client software like Go Ethereum or some other official Ethereum, their improvements, and the Ethereum consensus algorithm updates. And here are some types of EIP. The EIP standard tracks all requests touching in the protocol itself. Most of the EIPs belong to this category, and the matter all requests around the Ethereum protocol, and some informational ones. These EIPs don't invoke any changes to the code or the implementation. To be simple, it provides some general guidelines and some good practice or some informational items. And the EIP stage, there are lots of stages. The core stage of them is the idea. Idea is the Ethereum Improvement Proposal. It's still an idea. You come up with some idea, some thoughts about the improvements of the Ethereum system. So you can propose them as an idea, and you will draft an EIP proposal in the Ethereum database, but they are not very prepared for the review. And when you are ready, the review process is ready for the peer review of the Ethereum community. And then last call, final review of the EIP before changing states to review or to the final. There is usually a deadline about half a month. And the final one, the EIP is accepted as a new standard. So they are core stages of the EIPs. And EIP is kind of the improvement proposals, but EICs are protocol for proposing and standardizing new tokens and smart contract standards. Usually ERCs like ERC20 are derived from the EIP20, but they are mainly about the new tokens and the smart contract standards on the Ethereum blockchain. So the ERCs defines the rules and specifications for creating new tokens or smart contracts that can be used on the Ethereum blockchain. And there are some topics about ERC, usually about the token's name, token symbol, decimals, total supply, or some other items towards the tokens, and some smart contracts items. And the process of the EIP and the ERC are quite similar. When you come up with some ideas, you can write a proposal outlining the proposed change, its rationale, and the technical specifications. And you can submit it to the Ethereum GitHub repos as a pull request. And we'll go through a review process by the Ethereum community. The EIPs, maybe they will be reviewed by the developers and some community staff or some community contributors. But the ERCs, they can also be reviewed by the community, but most of the developers are focusing on the ERC changes. And when the EIP or the ERCs are reviewed, it will be assigned. It will be assigned with an EIP or some ERC numbers and added to the list of EIPs or the ERCs. So there are some difference about between the ERC and the EIP. Of course, the full form, the ERC is a Ethereum Request for comment, and the EIP is the Ethereum Improvement Proposal. And the ERC are more focused on the token and the smart contract standards, and the EIP are protocol improvements and changes. And the examples of the ERCs are ERC20, ERC 721. Most of us are knowing it. And the EIP 1559 and the EIP 155. And the ERC are always proposed by the developers and the community members, but usually the developers, because they have more ideas when they implement some, maybe they adopt to the ERC20 or some other stuff in their smart contracts, so they come up with some new ideas, so they will propose the ERCs. The EIPs are also proposed by the developers and community members, but there will be more community members participating in these EIP proposals. And the purpose of the ERC is standardization of token and contract design. And the purpose of EIP is the improvement and evolution of the Ethereum protocol. And the ERC, the ERCs are adopted by individual developers and projects. If you want to, you want to use a token in your smart contract, you can use the ERC20, or you can use the kind of the ERC 777 or some other forms of the ERCs, all according to your decisions. But the EIPs implement in the future version of the Ethereum protocol is a general protocol, so basically most of the Ethereum ecosystem will adopt the EIPs. And there are some reference because the EIPs and the ERC official site and some articles about their differences and similarities, and I will have some demo code of the ERC kind of the different definition or some others. And I will also send this PowerPoint to the Discord group later, yes. And we will go through the coding part. I will go through the kind of the websites of our items. The EIP, the URL of this is eip.ethereum.org, and this is the EIP proposals. All the EIP kind of definition, kind of the types, kind of the some more items are listed here. And there are another item called ERC in the tab, and we have lots of ERCs, ERC20, ERC55, or some kind of other EIP. They usually refers to maybe the future development of our smart contract or the whole Ethereum systems, and we can see some kind of the ERC, or I will maybe code explain the ERC20 and the ERC 721 for our better understanding of the ERCs. And ERC20, I will see. It's kind of the you can see the Ethereum.org. So when we search in the Ethereum.org, the official documentary, and we can see that we have the ERC20, this token standard, and there are some introductions of the ERC20 token and some definitions, items, maybe the methods, the events, and the examples, kind of the Python implementations or some issues or some kind of others. So the ERC20 or the other ERCs like ERC 721, they are all standards. So you can maybe develop a smart contract writing Solidity. So you need to follow these standards. So it will be recognized as a ERC20 token. It's kind of like this. It defines the methods. You have the number, symbol, decimals, total supply, and some other methods and some events. Maybe this all 11 kind of the definition is the standard of the ERC20. So when you want to implement ERC20 token, you can just I will see the interface. Okay, could you see it clearly? Okay. Okay. If you want to implement ERC20 token, there are two methods. The first one is you can define the interface of the ERC20 or just implement some methods according to the method defined in the standards. You should implement the name, the symbol, the decimals, and some other items. So you define them in the ERC20. So you implement all these kind of stuff in the interface of the ERC20, and you will input the interface of the ERC20 token, and you could maybe do the constructors and the name and the symbol, the total supply, implement the actual logics of the ERC20. So if you follow this kind of standards defined in the ERC20 kind of the ERC standard, it will be recognized as a valid ERC20 token, and maybe in some scans, Etherscan or some other scans, it will be recognized as a valid ERC20 token. And you can implement, or you can change, modify the whole logics according to your kind of the project needs and the requirements. I mean, you can have the total supply and the balance of transfer and allowance, some kind of other stuff that you define, because the standards only defines some kind of the method name and some visibility, some kind of the return type, or some kind of other stuff. It doesn't restrain the actual logics that how you implement the ERC20 token, how you implement this kind of methods. So you can have different, or you can have your special logics in the kind of the ERC20 tokens. Because if you receive the ERC20, you will emit some events. You can add more events, or you can do some if else, or some kind of other loops, or kind of other logics in the actual kind of the methods here. And of course, you can implement all these methods by yourself, and see you implement them in the interface, and you implement all the methods here. And another function, another method, if you want to implement your ERC20, you can use some like kind of the Open Zeppelin part. Yes, here. The Open Zeppelin have some kind of implementations of the ERC20, so you can just input maybe the ERC20 contract to your contract. So, and you will inherit the ERC20 contracts you input from the Open Zeppelin. So your token is maybe some contract of the ERC20 token defined in the Open Zeppelin smart contracts. So we have another implementation, the ERC20Y, and it's much simpler, and kind of that you define the contract, and this contract is the ERC21 and ERC20, and you have the constructors, and you have the mint functions. you use the mint functions in the constructor, and you don't need to define all other kind of methods defined in this interface or in the interface of the Open Zeppelin. So you just need to modify all the kind of the methods you want to do your customer or you want to change, so or modify or revise or some kind of others. So we have these two kind of the ERC20 implementations, and I will show it in the remix. And in our remix, also we need to see. If you are not familiar with the remix, you can refer to the remix.ethereum.org, and it's an IDE that you can write, compile, and deploy your smart contracts very easily. And we also use the remix D, so we don't need to write all the kind of the contracts, maybe new files. So we don't need to use these functions. So we will use the connect to localhost, and it will in the same directory that we develop our smart contracts in the SRC kind of directories. So it's the same, and we have the first one is the ERC20x.so. So it's our version of the ERC20 token, and we construct them in the kind of the name, the symbol, and the mint all the initial supply to the method.send. In your actual smart contracts, you should modify the constructor maybe to make it more flexible or kind of other things. That's just a demo. So we have the constructor name, symbol, total supply, balance of, transfer, allowance, approve, transfer from, and some other help functions. So we focus on this file, and we click the Solidity compiler, and we compile the ERC20 file, and we have kind of the IERC and the Invisible Garden token X. So we choose this one because in our contracts we import the IERC.so in our Invisible Garden token X. So we will choose the Invisible Garden token, and we deploy. And in our constructor, we need to pass initial supply in the constructor. So when we deploy the smart contracts, we need to define, or we need to set the initial value of the initial supply. Maybe we can have kind of like this one. So we deploy using these params, and we deploy it, and here is the deployed, and that's our smart contract. We can, okay.
Can you zoom in a bit?
Okay. Yes, okay. And when you define the IERC20, and you define the Invisible Garden token X, and when you deploy it, there are some functions that we define here, maybe some public variables, and some methods that we can invoke or we can query on, because like the decimals is 18, and because we defined here the decimal is 18, and the name, the symbol, okay, maybe much larger. The name, the symbol, and total supply. Total supply, when we deploy our contracts, we set the total supply. So here is the total supply we set in these contracts, and we can see that, okay, we can see that we use this kind of stuff, and we can try on some write methods, kind of the supply, because in our smart contract we mint all the initial supplies to the method.sender. Method.sender is of the constructor is contract deployer, because we in the remix we have some fake accounts, and the first account is the one we deploy this contract. So the 0x5b, this kind of the smart contract, this kind of account is the deployer. So it's also the message or sender. So we can see the balance of the accounts. We can copy the account here, or we can change to others and copy another one. So it's very useful when we want to transfer or we want to do some debugging or some tests on the smart contracts. So the first one, the 0x5b is our contract deployer, and so we copy this account address, and we invoke the balance of function method in here, and we will see all the initial supply. We set it here. The initial supply. All the initial supply will be linked to the method or sender is also our account, and we can do some other kind of like transfer. We will change to another account, maybe this account, and now we can see this account of the account of this kind of this account address is 0, because we don't have any tokens, and no one transferred to this account before. So the balance of this account is 0. So when we use the transfer or the transfer from is also okay, because we can use the kind of the change back to our contract deployer's account. So the 0x5bs. So we do the transfer, and we have the recipient, because we want this address to receive our tokens. Okay, and we have the amount, maybe kind of 100, but the decimal of this token is 18. So actually we need to add more kind of the zeros to the amount, but for the demo we don't need to set this. So we use the amount and the recipient, because when we invoking this kind of transfer method, we will do the first account will transfer 100 token to the second account. So we will invoke this method, and kind of we can see all the here. We from the status and the kind of the input and the output, or kind of others. You can see the decode input here. Okay, the decode. Okay, the decode input here, the address recipients and the amount, all kind of others from to, and some events. You can see events here, the transfer events, and the first arcs and the second arcs, and kind of other events. We can see it here, and we will go back to the contract here, and okay, here, and we will see the balance of our first account. First account is the 0x5b, and the balance of the first account is kind of like it's reduced 100 tokens because it transferred to another account, and we can see the balance of another account, the 0xab kind of the account address, and the balance of it is 100. So this is kind of the very simple implementation of the ERC20 token. We implement the whole tokens in our own. So we have the interface here. Because the ERC20 the standards proposed in the Ethereum website or some kind of the GitHub repos, it requires that you implement all the standards here, and you can add, of course you can add more methods here and or add more events here, but you at least you need to implement all these kind of standards that is required in your smart contract, so it will be regarded as the valid ERC20 token. And we will see another method, the ERC20, also the ERC20, but we don't, okay, we will delete these contracts first, and we go to the, okay, the kind of the, okay, the ERC20Y, and this is a very simple one because it uses the ERC defined, already defined in the Open Zeppelin contracts. So because you can go to the ERC20, you can see it in the kind of like Open Zeppelin docs, and we can see all the, I think it has the inheritance or the, I can see, yeah, ERC20 or, okay, here. It's the Open Zeppelin contracts repos, and we can see the ERC20 also. Kind of like it has some, also the IERC20 interface and some metadata, some context, and some arrows defined here. And it has some maybe kind of more complex than the one we implement. The one we use is kind of like just input the interface and implement some necessary methods. But for the Open Zeppelin ones, they have implement more logics. Of course, they also implement all the required methods in the standard, but they have more kind of error handling and kind of more methods here. So we can also use this one. So we just using the ERC20 constructors in our constructors. It's kind of like this. The ERC20 have this kind of the constructors in the smart contracts. We can see it in the, okay, we can see it. It has the constructors here in the ERC20, also in the Open Zeppelin contract. So it will pass the name and the symbol of your token. And in our smart contracts, we inherit the ERC20 from the Open Zeppelin, and in our constructor we can also use our kind of the father contracts, or kind of that one. So we can use the constructors in the Open Zeppelin ERC20. So we also pass the name, the symbol in the constructors, and we add one initial supply in our smart contracts, in our ERC20, the Invisible Garden token, and we also set the mint. So it actually implement nearly the same logics in our smart contract. So, but when we use them, it's much safer and kind of much simpler in our own code. So we can compile and deploy our contract here. When we compile it, we will have kind of like, it has maybe IERC 1155, one ERC20 arrows, and kind of other libraries or some contracts it input here. So in the remix we can have kind of compile either of them, because but we need to compile the final one because our Invisible Garden token is the some contract of the ERC20, and so we compile the final one, and when we compile it successfully, we need to deploy it, and it's the same. We deploy it requires the initial supply to be set in the constructor. Also, when we deploy it, we should set it. kind of like this, and we deploy this smart contract here, and it has here, and it's nearly the same. Okay, yes, it's the same, and so we have the total deploy. Okay, we have the total deploy. We pass in the deployment, and we have the symbol, we have the name, and when we invoke any methods here, there will be some logs or some more details of these transactions, and some kind of the decimals is also the 18. And we use the same test logics here, and the balance of our first account is the initial supply we defined when we deploy our smart contract, and kind of maybe they are more like the approve and allowance. So if you don't when you just want to transfer the tokens by yourself, it's okay. But if you want to delegate some smart contract to have some control or some access control to your tokens, you can use approve, and some of the smart contracts will have the ability they will be able to transfer your token, and another one, the transfer one, and also the same process. We have the second account, and we transfer it to kind of the 20,000, and also we use the balance of method, and the balance of is reduced by the amount that you transferred, and we have another method, and it has the total balance of the one that will be transferred from the account 1. So we implement the ERC20 token, Invisible Garden token X, and the Invisible Garden token Y. We implement this ERC20s in the different ways. One is your write all your code, and all the interface, all the method you implement, you write in your smart contracts according to the token standard. Okay. According to the token standard of the ERC20, and another method is to just use the one that OpenZeppelin already implements and revised. So, but the final kind of the efforts of these two tokens, they are nearly the same, and the Y is maybe more safer, and when you invoke them, it kind of gets optimization and some other benefits from the OpenZeppelin's its team or their engineers. And of course, you can compile, deploy, and test all the process in the remix. But we can also use Foundry to write some cut tests. We have some demo tests, kind of like this. Kind of like this. We can write some Foundry tests, because that we have the basic syntax of Foundry. You can find it in the Foundry book, or you can refer to some resources I sent it last week. So you can go to the Foundry book and have some kind of the initialization of the Foundry projects, and how you write some kind of the tests here, and how you write the Foundry tests, and how you invoke the kind of the specific ones, or the kind of like this. So okay, not this, the ERCs. So I will not explain too much on the syntax or some kind of others, you can refer to all these resources after our course. And kind of like this, we have the Invisible Garden token contract input from the SRC ERC20x.so. So we have the available that with the type of the Invisible Garden token X, and we have the address Alice and address Bob, and we have the initial supply that we set here, and we have some events here, and we have some setup. The setup method we will the function of the setup method here is when we run the test, the setup will run first. So if you want to initialize or you want to do some basic configuration of your contracts, you can use the setup. You can set you can bring all the logics here. So we have the token. The new function is that we talked last week that we can create a contract inside another contract. So in the test contract, we can create another contract here. So we have the token, and the new one is that we deploy the Invisible Garden token X, and with the initial supply, it's nearly the same with the method here. When we want to deploy a contract here, when we need to deploy a contract, we need to set the initial supply here. But in our But in our Foundry test here, we just set it as a variable because we defined here, and when we knew the Invisible Garden token X, we pass the list parameters to the new functions, and we have this kind of some other specific methods here that the expect image, because the kind of the transfer method, when we use the transfer, we will emit a transfer event here, because from the to the value we saw it here, so we can check that when we invoke the transfer method, it will actually the return value of all the parameters or some kind of other attributes of the event is nearly the same. It's almost it's totally the same with the transfer methods. Yes. So it's here, and it's our setup function, and
that will be called by when you create the contract. Setup will be called.
Oh yes, if you set it in the setup function, and when you run the test, this use the token.transfer, it will be called in the setup, in the test here. So it's just for test here, yes, and we can test some initial supply, some kind of that the assert equal. It's kind of we need the tokens total supply need to be the same as the initial supply we set here, and when we transfer, we will do this kind of also the same one. So okay, the assert here, the total supply is the same, and the balance of Alice is the same as the initial supply, because when we set up this test, we transfer all the initial supply to Alice. So the balance of Alice is the initial supply. So just for because when we knew this smart contract here, so we create a token here. The kind of like the deploy of this smart contract is this contract here. So the totally token belong to this contract, not to Alice or not to Bob. So we need to use a transfer from this test contract to Alice. So when we when we do some more complex tests, so the Alice can transfer to Bob and Bob can transfer to some other people, so it will be much convenient for us to understand. So we use the token transfer here just for tests. And it's kind of the initial supply, and it's kind of the test transfer here, and the amount we want to transfer maybe is 1,000, and the vm.prank method here is we want the Alice to invoke this the next method here. So the Alice will invoke the token.transfer. So the emit here, and it will also have the emit method emit event here, and we can assert that the final state of this is the success, and we can see that the balance of Alice is the initial supply reduced by the deducted by the amount, yes, and the balance of Bob is the amount. It's nearly the same test logic that or the test process that we manually operate in the remix. So it's here, and kind of others you can. I have the kind of the repo, so you can see all the tests or all the contracts here, so you can see it after class. So I will not go one by one, and the kind of the tests decimals and kind of some fail tests. So because when we use some fail tests, the execution of this method is expected to be failed, kind of like this. So when we want to transfer the more balance than we have, so this kind of function will execute it failedly, yes, and kind of the others. So if you use it in the kind of like, you can do the front test, and this command, so the it will run all the here, and you can use the method defined in the kind of like maybe you can match some specific contracts, and kind of like this. Okay. You can run it, match contract, and then okay. It will only run the ERC20x.t.sol. So you can or you can match the specific kind of the test, and you can maybe match the test here and one specific here, so you can test on your own. And this is about the ERC20 token, and about the ERC721 token is kind of like this. It also can be found in the official website here, kind of the token standards here. The ERC20 is the fungible. Fungible means that if you have one kind of the ERC, and I also have some kind of ERC, the two ERC of us are totally equal. But some kind of the NFT is non-fungible tokens, where you have the token number. Maybe you have the first NFT, and I have a second, and the attributes of our two NFTs are not the same, kind of like this. So it's fungible and non-fungible. And I think you are all familiar with the NFT ecosystem, and it also has some kind of the methods here, the balance of, the owner of, the safe transfer from, kind of the others, and it has some events here, and also the example here, with the same process here, I have the IERC 721 Solidity interface here, and we defined it the balance of, the owner of, totally the same as the standard here. So we implement our ERC-721 token here, the interface here, and when we have the ERC-721 token here, we the process of our development is totally the same with the ERC-20. So we have our Invisible Garden FTX, and it's some contract of our interface here, and we define some kind of the variables like owners, balances, token approved, and some kind of other kind of the token ID counter. It's kind of like if you want to mint one and another one, they just call mint, and they will get the token 2, and next one will get the token 3. So we use just a very simple logics here, and of course you can add more logics in your mint function, mint method here, like whitelist or some kind of random number or some kind of others. You can have your own implementations of the mint function, and also the construct here. When we deploy our smart contract, our ERC 721 smart contracts, we need to pass the name and the symbol here, and we have the name, we have the symbol, balance of, owner of, kind of others. And maybe one tricky information of here is that the mint function and the burn function are not standards in our ERC 721 standards. So if you have a ERC 721 token, you don't necessarily have the mint and burn function here. So maybe because maybe every NFT has some kind of mint and burn, so lots of people think the mint and burn are the standards, but they are not. So it's kind of like this. So we can just implement our mint function here, and you can have all your logic here, because the mint you can just maybe use some address, or you can have some other mint functions like kind of the maybe the token IDs and kind of other implementations, or you can have more params here, so you can implement your own mint function or kind of other functions here. Okay, yes. So, and you can also have your burn function here. So this kind of and I will also see it in the remix. In our remix, okay, I will use the remix D here. Remix D is a command line provided by the remix IDE. So when you run remix D in some directories like the SRC, it will show in the local environment. I run the remix D here, and I use the connect to localhost and connect. So I don't need to, so I can just write some code here, so it will automatically appear in the remix IDE. So because I think it's not very powerful, less powerful than the VS Code. Okay, here. We have the ERC20, we have the ERC721X here, and we can see it here. Okay, kind of like this. Okay, kind of like this. We have the Invisible Garden FTX, and it's from the ERC20 here, and because the interface we also defined by us, also write by us. It's implement all the kind of the methods needed in the standard here. Okay. Standard here, kind of like this here. So we implement all the standards here, and we go back to the X and we have the token counter name, kind of others. And when we compile our smart contracts here, we need to compile this one, the Invisible Garden FTX. So it may kind of other contracts here because we use the ERC kind of the receiver here or kind of other here. So we need to compile the here and when we use it here, and when we choose our contract, the Invisible Garden FTX, and we need to define the name and the symbol here, and because the name, kind of the name of this Invisible Garden FTX and the IGNX, kind of like this, and we use the local environment of the remix, and we can also use the kind of like the MetaMask provide. We can connect it using maybe the kind of the test nets of the maybe Sepolia or some kind of other blockchains. But for simple demo, we just use the local environment here. And when we deploy it, we need to pass the two methods. We need it here, and we can see it in our smart contracts because it's in the constructor here. In our ERC 721 smart contracts, we need to pass the name and the symbol here in the constructor here, so we need to use it here, and we deploy it. When we deploy it here, we have more functions than the ERC20, but we need to check the name and the symbol here. The name is defined in the Invisible Garden FTX, and the symbol is the IGNX. We set it just here, and kind of like we need to maybe mint the first NFT of this Invisible Garden NFT, and we can also maybe we use another one. We use a third account address here, and we go back to the account. We want to mint like this. We want to mint the first NFT to the third account of our blockchain, so we use the mint, and it's here, and we can use the balance of this account is is 1 because we minted it just before, and we can use the owner of because kind of like we start our token by 0, so I will use the 0. Okay. The owner of token ID 0 is we can see the owner of the token 0 is the 0x4b, and maybe we can try 1 and kind of like this. It will have some error because 1 is not in here. We can see we have some revert because the invalid token ID we defined here because the NFT with token ID 1 is not mint here, so it's in the contract but not mint to any account here. So when we kind of transfer or when we query the owner of this NFT, it will fail. So it's kind of like this, and we can kind of like transfer here. Okay, save transfer here, save transfer from, and transfer from, and kind of others. We can like use we can go to the third one, and we can copy the first address, and we can use it. We can use the save transfer from here, and the from is the B, and the 2 is 5B, and the token kind of like this. The color is not token here, so we maybe need to use another count or kind of like because when we invoke all the contracts here, so we can have all the kind of revert arrows or some hints in the smart contracts in the terminal consoles, and we have lots of other hints here. And when maybe kind of like this, we have the on-off, and we want to the kind of the 0 here, and we can kind of test the burn function here, and when we burn it, okay, we can mint it for another one, and maybe the 5B here, and the mint another one, and the owner of the token ID 1 is the first account here. So when we use burn here, maybe we are the first account here is the owner of our token ID 1, and we can burn it, and it's here, and then we query of the balance of function, and balance of this one is to be 0, and the owner of 1, when we revoke it, kind of the invalid token ID because it's burned already. It's kind of like this, and this is some basic concepts of the NFT token. We implement all this by ourselves, but just like the ERC20, we don't need to implement all the logics by ourselves. We can use the already implemented one from the Open Zeppelins because they have more error handling, so they are more safer, or they have some more features here, because we can define as the Invisible Garden NFT Y, and it should be inherited from the ERC 721 from the Open Zeppelin contracts repo, and we also nearly the same. We use the constructor, but we use the ERC 721 constructor here, so we don't need to implement all the set logics here, and we implement the mint and the burn function here. So because we just need to maybe do some customization of the mint and burn, and keep all the features of the NFT with the same as the Open Zeppelin that's already implemented. So we only want to modify the mint and burn function here. So we don't need to list all the functions here. We don't need to do that. So we just use the mint and the function and the burn function here, and of course we can compile it as Y, and compile it to the ERC Y, and okay, we can delete all the deployed contracts here, and Invisible Garden NFT Y here, and so the one using Open Zeppelin and is the same with nearly the same with the one that we do it ourselves. So also Invisible Garden NFTY and IGN1Y. So we just deploy it using the first account here, and when it's deployed, it will appear here, and it have kind of the more methods here, and the burn and some kind of others, and the symbols of this is here, and the name is here, and the owner of we don't have any tokens here, so the owner of we can call here, and we also the mint here, and mint the first token, and the owner of token ID 0 is our account here, the same as here. So, and we can transfer, we can burn is totally the same. We can burn it here, and we can see the balance of the one is expected to be 0 because we burned it, and we can also burn it again, and the balance of it will be 1, and burn it again it will be 2. It's kind of like this. So we can just write kind of like the 10 or 20 lines of code that we can have our own NFTs here. So you can write it on your own, and of course we have all the Foundry test here, and you can refer it to it after this class, and I will not go through it, and okay, I will say kind of like this. The test here is that the Invisible Garden NFT Y is the NFT because the type of this variable NFT is the contract. Contract can also be a type. Like we always have kind of like the int, or maybe it's a kind of boolean or kind of address as our address, but the contract can also be our type here, variable type here. And we have the Alice, we have the Bob, we have the initial token ID. We can also init our token from 1, or you can from 100 or more or bigger if you like. And we have some event to compile the final output or some kind of others. And we set up it here because we create the NFT here, just like the deploy contract here. Here we deploy contract here using the new here, and we mint the initial token to Alice, and kind of like the same one, and test the initial owners, and test the transfer. We can, like the prank is like the Alice will invoke the very next function is the transfer from here, and it will transfer the tokens from Alice to B and the initial token ID, and we can have some comparison, and we can test the mint, test the burn here, and you can refer it to yourself. And we can also run some tests. We can run the forge test match contracts. We can kind of use this. Okay. Yes. We can run the test here. So just use the test burn, test initialization, and test the mint, test the transfer. We only run the test here. And another tip is that if we want to see more details about our maybe test, we can have some maybe 5V, so we will have the cost stacks here, because when we call the test transfer here, we have the print, we have all the details that the actual execution and the expected ones, and the number of V, maybe the 3V, we only because I can have a try. Yes, it's kind of like this test mint. Maybe I deliberately changed some logic in the test, and I use the 3Vs here. And if one of these is maybe is failed, the failed one will have the cost stack. So we don't need to have all the cost stacks here. So it all can be found in the Foundry book or some official documents here. And I think that's all for today's introductions or the explanations to the EIPs, ERCs, and some coding practice of the ERC20 and the ERC721 here, and I will send the demo code here and some resources links and of course the PPTs to the Discord group. And if you have any questions, you can ask here, and I will. And Daniel and me will answer here. Thank you. Okay, I will see. Okay. I will send all the links